is Born Isaac Bear from Bear Science Lab. Sorry it was a little delayed there. Today, we're taking on a three-dimensional geometry problem, specifically one from the AMC 10B 2022. Today, we're back after a long hiatus on question number 21. Alright, so let's continue. So here's just a sneak peek what we'll be dealing with today. That's a magnificent fruit bowl, don't you think? Alright, so let's just take this here. That attaches. So, here we have this bowl. And you can see these hexagon-ish shapes. Sorry, I had trouble copying the diagram onto paper. And these triangles. Now, it specifically tells us on the question that these hexagons, sorry, that's not a hexagon. These hexagons are equilateral and have a side length of 1. So phew, we are dealing with equilateral hexagons. But wait, it doesn't tell us anything about anything else. So, what are we to do? Well, now we have to find the octagon formed over here at the top of all of this. So, we already know 4 sides of this octagon. That's the good thing, because 4 sides of it are made up by these hexagons. So, we already know this is 1, this is 1, this is 1, this is 1. But now, here's a creative solution. Even though it is not a regular octagon, when you extend these sides, it creates a perpendicular angle. Not a perpendicular angle, what am I saying? A right angle. So, let me explain. So, you know what? Let me give these little lines names. So, why don't we call this L? How do I draw it on here? So, let's call that L. Let's call this M, and let's call this N. So, let's say we extend M, and then we extend N, and then we extend L. Now, they all seem to meet up at one point over here in the middle, but how are we sure that it meets up at one point right in the middle? Well, let's see. We know that since L must intersect the top plane, which is basically fancy word for the octagon, at least once, then it must also intersect M and N. And since M and N are on this top plane, they're same sides of an octagon, they must intersect each other. Because they're not opposite sides of an octagon. So, that means that as well, because there are 2 sides of an octagon that are separated by one side, pretty clear that all of these are right angles. Because that's what you get when you extend 2 sort of kind of adjacent sides of a triangle. But the thing is, even though these things are clearly congruent, we have no idea what their side lengths are. So let's find them. So we know that this is 1, this is 1, that is 1. However, since L, M, and N are congruent, then L, M, and N, these little things that make them meet up at the center must also be congruent. So, if you look closely, you will notice that this actually kind of makes some equilateral triangles. You don't understand? Let me kind of draw a diagram just to set the field. So this is M, this is N, and this is L, right? So, when you take M, kind of creates this triangle over here, even though we don't know if that's equilateral or not. It also creates this triangle here, but we know that one is equilateral, and it creates this one here, which we know is also equilateral. Alright, so now, since this is 1, this is 1, and this is 1. Since this is 1, this is 1, because they're equilateral triangles. And here, remember from this diagram, this angle is a right angle. So using the Pythagorean theorem, the hypotenuse of a right triangle with legs 1 and 1 is root 2. So now we have these all over. We don't really even have to find the hypotenuses. This is actually pretty easy to do, because once we find out this, we realize that this octagon is simply a square with 4 tiny triangles of 1 by 1s factored out. So that's 3 squared minus 2, which is 9 minus 2 equals 7. That's it. Thank you everybody for watching. We'll see you in the next one.